Okay, we are on page 4 in our Unit 2 notes packet for today. We're going to talk about function notation for today. And then tomorrow we're going to talk about function notation. And then the next day we're going to talk about function notation. We're going to spend a decent chunk of time talking about function notation. Okay, the function notation is something that we want to be comfortable with. It's something we want to be able to use because it makes a lot of our writing about graphs, about tables, about relation maps a lot easier and a lot more concise if we can use what we call function notation. So that's what we're going to see today, and that's what we're going to work on for the next few days. Now, yesterday we talked about what is a function, right? That was our big idea. What's the difference between something that's a function and something that's not a function? And so you guys can stay on page 4, but very briefly, I just want to flip back to page 2 and make a little bit bigger deal about this statement right at the top of page 2. Okay. This is what we were looking at yesterday, even though we didn't explicitly phrase it this way. So our idea yesterday was we wanted to be able to find situations, right? Everything that we talked about yesterday had some sort of context. We want to be able to find situations where if I have 13 bagels, that was one of our problems yesterday, I know exactly how much I'm going to have to pay for those 13 bagels. It's not dependent on how somebody rings it up on the register, right? That's a function. And so what we're looking there is for each input, right? However many bagels I'm going to buy, we have exactly one output. We know what that cost is going to be. That's how we describe a function. For each input, there is exactly one output. Okay. So if we think back to our pattern at the top of page 1 that we started with yesterday, for each step in this pattern, my input, I know exactly how many stars there will be, right? That's my output. So for each input, I have exactly one output. That's our idea for a function. So on page 4, we're going to start talking about something called function notation. And the idea here is that we're going to look at ways that we can describe these input-output pairs for functions in a really concise, efficient way, okay? So at the top of page 4, the example we're going to start with is that we've got a dog that is attached to a post, okay? And their owner has left and then returned, okay? Does anybody have a dog? Okay. Is anybody's dog, like when you come home, is like right there at the door waiting for you? Okay. So when I take my son to the bus stop in the morning, we go out the front of our house and we've got a fenced backyard, but there's a little gap under the gate for the front fence. And one of our dogs will stick his face right under that gap and watch as we walk to the bus stop. And then my son gets on the bus. And then when we walk back down the sidewalk home, our dog's sitting there with his face under that gap, watching us. And then the second that we're actually in front of the house, like we're gonna walk in the door, he bolts back away from the gate and into our house through the back door. Okay, so that's kind of the situation that we're seeing here, right? Our dog waits for us to leave, watches us, waits for us to come back, and then goes to greet us at the door. That's kind of the situation that we've got here. So we've got a description of this dog's behavior on 3 different days. So on day 1, he starts some distance from the post. He kind of meanders around, then comes back kind of towards where he was originally, right? That distance is decreasing. And then the 160-second mark, as we'll see in just a minute, is when our owner comes back. For day 2, he starts here and then meanders a little farther away from the post and then comes back, and then he finds a spot and he's in that same spot. Maybe he laid down, maybe he found something interesting to sniff, but he stayed in that one spot. And then for our 3rd day, he runs away from the post or his original spot and then kind of meanders back and then maybe lays back down towards the end. Okay, that's what we see here with our dog. So we're going to use each of these graphs to be able to describe where our dog is at different times while the owner is gone. So how far away was the dog from the post 60 seconds after the owner left on, we're going to start with day 1. So 60 seconds. So for day one, 60 seconds, that dog was how far from the post? 4 feet. Very good. 4 feet. On day two, 60 seconds, that dog was how far away from the post? 4 feet again. And then on day three, here's 60 seconds. How far away from the post was he? 4 feet again. Now for question B, I want to know how far away was the dog from the post when the owner left? So what time would we be looking at when the owner left? What would be our time? Oh, yep, I saw it. 0. Yeah, so we're looking at 0 seconds. So on day one, at 0 seconds, how far was the dog? About 1.5, it looks like, 1.5 feet. How about on day two? Looks like 1.5 again. And day three? Yeah, 1.5 again. C says the owner returned 160 seconds after he left. How far was the dog from the post at that time? So 160 seconds is the very edge of our graph. That's the last time that we have recorded here. So there's our dog at 160 seconds. How far was he from the post on day one? We have to estimate a little bit here. That's okay. Give me your best estimate. 3.9? Sure. 3.9 feet. Sounds good to me. If you disagree with that estimate and you think it was 3.8 instead, that's fine. You can put 3.8 as long as it's a reasonable estimate. Day two, 160 seconds. How far was he? 4 feet. Yep, don't have to estimate on that one. He was at 4 feet. And then day three, at 160 seconds, what was that distance? About half, 0.5. Again, if you disagree with that estimate, you think it was slightly higher or lower, that's okay, as long as your estimate is between 0 and 1, towards the middle of those two. Okay, and then part D. This time I'm asking how many seconds, so I'm asking you for a time, how many seconds passed before the dog reached the farthest point it could reach from the post. If I'm looking for the farthest distance, what will that look like on the graph? The maximum, yeah, the highest point on the graph. I want the greatest distance. The distance is the y. So I want to look for the maximum on my graph. So on day one, here's my maximum. About what time does that correspond with? Roughly 50 seconds. That sounds good to me. How about day two? Here's our maximum for day two. Anybody want to give me an estimate for that time? 35 sounds good to me, 35 seconds. And then for day three, our maximum distance is like right away. What'd you say? 5. It's not quite 0, right? We're off that axis a little bit, but it's not a very big number. So 5 was the smallest number I heard thrown out. Let's go with 5. Oops, let me scoot this up a little bit so you guys can see those. So we did the same thing here that we did in Unit 1 with our graph stories, right? We had graphs that represented some information, okay? We had 2 variables here, and we pulled information out of those graphs based on what we saw there. So sometimes we were looking for that X value, that independent variable, in this case, a time. Sometimes we were looking for a distance, right? Our dependent variable or our Y. Okay, so this is exactly what we did with our graph stories. Now I want to take it one step further and use these scenarios to introduce and talk about something called function notation. Okay, so if you would for me, please turn the page to page 5. And now, instead of having to say on day 1, on day 2, on day 3 each time, we're going to give some notation to each of these different days. So day 1, we're going to call f of t. Day 2, we're going to call g of t. And day 3, we're going to call h of t. Okay? So anytime I talk about day 1, I'm going to use f. Anytime I talk about day 2, I'm going to use g. And anytime I talk about 3, I'm going to use h. Okay, it's sort of like an abbreviation, okay, this notation that we're going to use here. The input for each function is our time, okay? Remember, input is like those x values, okay? So the input for each of these would be time. That's why we're using t. If the input is time, what would be the output? What's the other thing that we looked at? The distance, right? The feet. Okay, input is time, right? That was our second. The output would be feet, that distance that we measured. So what we're going to do is take a lot of the information that we just gathered and write function notation. Okay, we're going to abbreviate it, shorten it up to function notation. So we want to write in function notation the distance from the post 60 seconds after the owner left. So I've got all of our records here on my other page, so I'll jot those down for us. For every day, 60 seconds after the owner left, our dog was 4 feet from the post. So on day 1, so if I'm talking about day 1, I'm going to use F. So on day 1, 60 seconds. So in those parentheses here, I'm going to put 60 because that was my time. Our dog was 4 feet from the post, so equals 4. I would read this as f of 60 equals 4. So this is a function notation way to say that on day 1, 60 seconds after the owner left, the dog was 4 feet from the post. So I could say that big long sentence, or I could say f of 60 equals 4. And I'm saying the same thing. I get the same information across. The difference is that this is way shorter. For day 2, we're going to use g. So g of 60 equals 4. That distance again was 4 after 60 seconds for day 2 from our graph. So g of 60 equals 4. So this tells me that on day 2, 60 seconds after the owner left, the dog was 4 feet from the post. And then for day 3, I want to use h. H describes day 3. We're still talking about 60 seconds after the owner left. So h of 60. And that distance was again 4, so I'm going to write equals 4. So the stuff we had in sentences on the last page, we've written in function notation here. Questions for me so far? Okay. Now we're going to write about the distance from the post when the owner left. What was our time when the owner left? 0, yeah. So our t here is 0. And when the owner left each time, our distance was 1.5 feet. So for day 1, that would be f of 0 equals 1.5. For day 2, our function is g. So g of 0 equals 1.5. And then for day 3, we want to use h. That's the function that we had defined for day 3 of 0, since that's the time we're looking at, equals 1.5, since that's the distance that we had when the owner left. Not too bad? Okay. Way shorter to write function notation than to write that out in a sentence, right? Yeah, that's why we like function notation. Now I want you guys to try this last one. The distance from the post, 150 seconds after the owner left. And just to help you out, I will, or this should be 160. Just to help you out, I'll give you those measurements that we had. So for day 1, it was 3.9 feet. For day 2, it was 4 feet. And for day 3, it was 0.5 feet. So the measurements were all a little bit different here. I want you to give me function notation for each of those days when the owner returned. So this should be f of 160 equals 3.9. Since it's day 1, we're using our function f. Our time was 160 and our distance was 3.9 feet. For day 2, that would be g of 160 equals 4. So g, because that's our function for day 2, our time was 160 seconds, our distance was 4. For day 3, this would be h of 160 equals 0.5. So this is telling me on day 3, after 160 seconds, the dog was 0.5 feet from the post. Questions on our function notation so far? Okay. So here we've taken our statements and put them into function notation. Function notation is a great, concise, short way to be able to represent our information, but it doesn't do us a lot of good if I don't know what this stuff means. So if I give you function notation and you're not sure what the function is telling me, or what the input is, or what the output is, then it's not very helpful. So the next thing I'm going to do is practice pulling that information out of function notation. So if we see function notation, what is it telling us? So for number 2, I want to describe what each of these notations is representing in the context of our problem. So we're still talking about our dog. So we still got functions f, g, and h. So let's talk about what we're seeing here. So for A, f of 15. Function f means I'm talking about what? Day 1. So I'm going to start off with on day 1. And then what's this number in parentheses represent? It's a time, yeah. On day 1, this is telling me 15 seconds after the owner left. On day 1, 15 seconds after the owner left. It doesn't give me a distance, so I'm not going to include a distance. Now for B, I've got g of 48. If I've got function g, what do I know? It's day 2. So on day 2, and then what does the 48 represent? Time. We're 48 seconds after the owner left. For part C, I've got h of t. What does the h tell me? Day 3. On day 3, And then they didn't give me a number here. They just gave me t. I know that t is a time. They just haven't given me a specific time. So I'm going to say t seconds. When they gave me 15, I said 15 seconds. When they gave me 48, I said 48 seconds. So here I'm just going to say t seconds. T seconds after the owner left. T seconds after the owner left. Okay. They left it in general terms, so I'm going to leave it in general terms. Now for number 3, I've got the same stuff that we had for number 2, except for equals something. What are all of these equal to? What was the equal to number? Yeah, distance, how many feet the dog was from the post. So if I look at 3A, it says h of 40 equals 4.6. What does the h tell me? The day, and what day are we on here for h? Day 3, on day 3, on day 3. What's the 40? The number of seconds? 40 seconds after the owner left. And then 4.6 would be the feet that the dog was from the post. The dog was 4.6 feet from the post. On day 3, 40 seconds after the owner left, the dog was 4.6 feet from the post. I would like you now to try B. F of t equals 5. Write out in words for me what we're representing there with that function notation. Check your answer for B. I wrote mine on another sheet of paper just because I'm writing with a marker, so my space is a little tight. This is what you should have had. So f of t equals 5 is telling me on day 1, f is my function for day 1, t seconds after the owner left. They didn't give me a number here, so I just left it at t. T seconds after the owner left, the dog was 5 feet from the post. My distance here is 5 according to my notation, so the dog was 5 feet from the post. Questions for me on B? Okay, and then let's look at C. For C, they didn't give me any concrete values. So just like we used t seconds in B, we're going to use t seconds here, and then we'll do D feet. So G is what day? Day 2. So on day 2, t seconds after the owner left, the dog was D feet from the post. They didn't give me any specifics there, so I left it with the T and the D that they gave me. Questions for me on page 5? Okay, let's turn to page 6. So on page 6, we're gonna combine what we talked about yesterday with identifying if we have a function or not with the function notation that we're looking at today. So at the top, I have rule B and rule P. We're going to decide in a couple minutes if these are functions or not. So since we don't know right now, we're just going to call them rules. Rule B takes a person's name as its input and gives their birthday as the output. So we have an example here. Our input is Abraham Lincoln. Our output is February 12th. Does anybody in here have that same birthday? Any February 12th birthday people? Okay. So I'm going to give us a couple more made-up people to fill out our table. So made-up person number 1 is Marcus, and his made-up birthday is June 5th. Made-up person number 2 will be Megan, and her birthday is August 20th. And then made-up person number 3 is Angela, and her birthday is June 5th. So rule B, I take your name and I output your birthday. So your name is the input, your birthday is the output. For rule P, I take a date as the input and I give you a person with that birthday as the output. So you give me a date and I tell you somebody with that birthday. So we can take our same information that we have in this table here and just flip the input and output to get some information for rule P. So for rule P, if I input February 12th, my output could be Lincoln. If I input June 5th, my output could be Marcus. If I input August 20th, my output could be Megan. If I input June 5th, my output could be Angela. So we've got some tables, right, with some input output pairs to be able to refer to as we talk about if these are functions or not, and then work on that function notation a little bit more. So in rule B, if I put my name as the input, how many possible outputs are there? 1, right? You have 1 birthday. Okay, you list it on your birth certificate. It's 1 date. They can't list multiple dates. So you have 1 possible output, and it's your birthday. Now, let's say we list your birthday in our input-output table. If your birthday is the input, how many possible outputs are there? We put your birthday in. Why would there be a lot of options? Yeah, we've got like, I don't know, 7.5 billion people, something like that on the planet. Yeah, chances are pretty good that somebody else has your same birthday, right? Do I have anybody in here who is a multiple, like a twin or something? Okay, so you got more than one, more than just you has the same birthday, right? Now, what would be really great if you were like, actually, Mrs. Lucia, I was born at 11:58 p.m. and my sibling was born at 12:03 a.m. So we don't have the same birthday. You guys have the same birthday? Yeah. Okay. Yeah, lots of people have the same birthday. Okay. So is there only one person ever that's born on February 29th? So like, even if we pick a day that doesn't have a lot of options for people to have that birthday, we still have more than one person with that birthday, right? So probably our number is fewer for February 29th, but it's still more than 1. So how many outputs are possible? Many, because lots of people have the same birthday. Have the same B-day. Lots of people have the same birthday. So if my input is a date and my output is people that have that birthday, I'm gonna have a lot of outputs for any date that I wanna pick. So which of these would be a function? Which of these fits the definition of a function? Remember, for a function, for one input, I've got exactly one output. Which of these rules would be a function? B would be a function. My input is my name, my output is my birthday. I'm only gonna have one birthday. Everybody's only got one birthday, so rule B is a function. For each input, I have exactly one output. So rule B is a function. Because each input I'm gonna write instead of name here, I'll write person. Each input, which is a person, has one output. And remember, output would be our birthday. Each input has one output. Each person has one birthday. So the last thing I want to do here is, again, practice our function notation. Okay. So this time we've got information that isn't just numbers. That's okay. I can still use function notation here. So I'm going to write 1. I'm going to use our first line in our table. So since this is called rule B, I'm going to use B as our function. So B of Lincoln, right? That was our input, was people. And then our output was birthdays, and his birthday is February 12th. So B of Lincoln equals February 12th. I would like you now to write one more input-output pair in function notation. You can pick one of our made-up people from the table, or you can write yourself. So give me one more, yourself or one of our made-up people from the table. Give me function notation of an input-output pair. Questions for me on page 6? Okay, so the last thing I want to do is look at just a couple of problems on page 8. So flip to page 8 for me, please. On page 8, we have no context whatsoever, okay? We don't have information about our dog from the start of today. We don't have any information about horse days. We've got no context. We've got a bunch of different descriptions of functions and relations, no context to any of them, okay? So we've got a couple of tables. We've got a couple of input-output maps. We've got a couple of graphs, okay? No context here. We're strictly looking at that function notation, okay? So we're gonna take a look at a couple of problems here. Really quickly, I would like to point out that number 3 has a typo. It says R of 7, it should be F of 7. There is no function R. Change that to F. And now we're going to look at number 2. Number 2 is G of -2 equals something. We want to say what it equals. Remember that that number in parentheses is always our input or our X value. And then what we get out is our output or our y value. Okay. So function g is which of these? Which of these is function g? The second graph. Yep, g of x, they're all labeled. So f of x, p of x, m of x, k of x, s of x, and g of x. So we're looking at this graph here. And I know that the input, the x value, is -2. So I want to go to when the x value is -2. That would be right here. And then the point on my graph that has an x value of -2 would be this guy right here. So that point is -2, comma, -1. So to complete this, g of -2 equals -1. So using my graph, they gave me an input. I found the output that matches. Does that make sense, what I've done there? And we worked only in function notation on this one. Now let's take a look at number 4. Same idea. This time I'm working with function k. So k of 1 equals, see, k would be this input-output map right here. I've got the input. So here's the input. K of 1 equals, what's its output? 1. Yeah, 1 goes to 1. K of 1 equals 1. Now let's look at one more. Number 14, down towards the bottom. P of x equals 32.5. This time I've given you the output. I want to know the input. What's the input that I'm missing here? So I'm going to go to P of x. That's this second table here. And I know the output. So I want to be in this column. Okay. My output is 32.5. So I'm going to go until I find 32.5. And then I want to know what input gave me that. 40. So P of x equals 32.5. That means x has to equal 40. Does that make sense what we've done there? So for each of these, you want to find the function. So you're going to look at that letter to decide what function. For some of them, I've given you the input, and I want you to tell me what output matches. For others, I've given you the output, and I want you to tell me what input got there. Okay. So your homework for tonight is page 7. Page 7 is more practice, sort of describing what we're seeing with function notation. So what we did towards the start of class. So page 7, and then on page 8, just the odds. All of page 7, but on page 8, just the odds.